Hi, my name is Joseph Derenthal, and for this project, I developed a passive posture feedback harness. This device is designed to provide simple, low-cost feedback to help users recognize poor posture through self-correction instead of forced correction. So poor posture is very common in daily life, especially with the increased use of phones, computers, and other electronic devices. It's easy to sit or stand with poor shoulder positioning for extended periods of time, which over time can lead to discomfort, muscle tightness, weakness, and overall strain. Many of the existing posture correctors attempt to solve this by constantly pulling the shoulders back into proper alignment. And while this can improve posture in the short term, it does not encourage any long term habit development since the device is doing almost all the work instead of the person. There are also more advanced solutions such as biofeedback devices that use sensors and vibration alerts. However, these systems tend to be more complex and expensive than it is necessary. This led to the development of a simple, more passive solution. So the overall goal of this project was to develop a low-cost posture feedback device that is both simple and effective. A key design requirement was that the system remain passive, meaning it does not rely on any electronics or external power. Additionally, the device should not force the user into correct posture. Instead, it should allow natural movement while providing any feedback when slouching occurs. This encourages the user to actively correct their posture, helping to build long-term habits rather than relying on the device itself. These requirements led to the final design. So here's the proposed design. It is a passive strap-based system that provides feedback through tension. Elastic straps run over the shoulders, connect across the upper back using a central back connector. This allows for natural movement while the straps remain properly positioned on the body. When the user is in good posture, the straps remain relatively relaxed and do not apply significant tension. However, when the user begins to slouch, the straps stretch and create tension across the shoulders, which provides immediate physical feedback. This feedback will then prompt the user to actively correct their posture rather than relying on the device to hold them in place. This concept was then developed into the final prototype on the next slide. This slide shows the final prototype of the device. The design consists of two elastic shoulder straps connected across the upper back using an extended back connector. And in the initial design, an elastic strap was used as a back connector. However, this resulted in pretty excessive tension even during proper posture, which made the device feel more like an active brace rather than a feedback system. To address this, the elastic connector was replaced with a towel, which increased the overall length and allowed the system to remain relaxed during proper posture. The final configuration provides minimal tension at rest and increased tension when slouching occurs. The performance of this final design is demonstrated in the following video. This demonstration shows the performance of the final prototype from both a side view and a back view. As you can see, whenever I am in proper posture, the shoulders are aligned and the straps remain relaxed with minimal tension. And as I begin to slouch, the shoulders move forward, and then this makes the straps stretch, which then creates a noticeable tension across my shoulder. You can see this by how it pulls on my shirt and looks rather uncomfortable. This will provide immediate mechanical feedback, prompting the user to return to proper posture. And then once the posture is corrected, the tension in the straps is reduced and almost non-existent. Overall, the device is able to distinguish between proper and poor posture and provide feedback without restricting any movement. And this demonstrates that a simple design can effectively provide posture feedback without any need for electronics. As shown in the demonstration, the device was able to clearly differentiate between proper and poor posture. When I maintained proper posture, the straps remained relaxed with minimal tension, and then as I transitioned into a slouch position, the straps stretched and created noticeable tension across the shoulders. This tension provided me immediate feedback, prompting me to correct my posture. And overall, the device functioned as intended by providing consistent passive feedback without restricting natural movement. Based on this testing, several areas of improvement were identified. And first, improved material selection could increase the overall comfort and durability, especially for any extended use. Second, the design could be enhanced with a more adjustable strap system. This will better accommodate different body sizes and improve overall fit of the device. And finally, adding padding in high contact areas such as the shoulders and underarms could reduce pressure and improve overall wearability. These improvements would enhance comfort, adaptability, and usability while preserving the simplicity of the passive design. In conclusion, this project demonstrated that a simple mechanical design can effectively provide posture feedback. The device encourages active, user-driven posture correction rather than forced correction through constant support. This allows the user to engage the necessary muscles, which may lead to improved long-term posture habits. Additionally, the design eliminates the need for complex or electronic systems, making it both a low-cost and accessible solution. Overall, this work demonstrates the feasibility of using a passive system to promote posture awareness and support long-term posture improvement. Here are my references, and thank you.